All right, so let's get going. Welcome, everyone. This is Joe Armstrong in the April version of the Power Systems Virtual User Group webinar series. I got the recording on, so it's not like anybody else says anything, but I just want you to know that this is being recorded. And with that, I'll go ahead and say that the replay for this, I'll put a link on the wiki site as soon as I get it uploaded, probably at least by tomorrow sometime, I hope, assuming that WebEx gets it formatted right for me. And then also the presentation materials that we're going to go through today are already on the wiki site, so you can download them from there. If you have questions to ask during the webinar, please put them in the Q&A panel, not the chat panel. That way we don't have to check two panels. So put your questions in the Q&A panel, please. So just to get started, I want to, again, welcome everybody here. I know these are interesting times with the whole COVID-19 thing. I'm sure you're tired of hearing about COVID-19. That's all that's on the news, it seems. But I just want to say I hope you're all doing well. I know it can be quite trying for people, you know, working from home or people who have lost their jobs or whatever right now. So I just hope that everybody in the community is doing well. IBM is doing a lot, as we heard a couple of weeks ago on this. And let me just, you know, if your company or you is having some issues with IBM stuff or something that IBM can help with and you don't know where to turn to, you don't have a sales rep that you know or a business partner or something, feel free to drop me a note. I'll route it as best I can to get something. So just if you're having some technical difficulties or something like that, feel free to drop me a note, Joe Armstrong. You can reply to any of the messages that you get from me on this. So anyway, just wanted to let you all know that. A couple of things for the webinar series. I've kind of been on the ball and gotten the May and June series set up. So just to let you know, in May we're going to be talking SRIOV, Single Root I/O Virtualization, and some cool stuff about that, migrating to that, and also a neat tool that the Lab Services has that makes migration easier. For June, we're going to talk roadmaps. You know, these days we talk a lot about cloud, cognitive AI, machine learning, and I think a lot of the AIX and IBMI kind of gets just forgotten about. But they both have very long history, or very long and strong futures in IBM. So we're going to cover roadmap for AIX and roadmap for IBMI. I've got both the offering managers lined up to talk about that. We'll probably cover a little bit extra besides just roadmaps, but stay tuned for that. And also next week starts IBM Think 2020 virtual or digital, I think they're calling it, conference. So you know, with this all the COVID-19, the Think conference is a huge conference in IBM. Some drawbacks to this, doing it digital, is you can't go to whatever cool site like San Francisco. Don't get all the parties and stuff at nighttime. The benefit is you can go to the sessions you want. You don't have to travel. You don't have to spend all those days being away. You can fit this in, and it's now free. So if you want to register, go to the Power Systems Bug Wiki, and I'll throw up a URL for that later when we get going here. But go there, you can register for Think, pick out the sessions that you're interested in, and just attend those sessions. All right, great stuff there. So with that, let's get to today's topic, Ansible on AIX. So Ansible is one of those tools, and we all use a lot of tools in our kitchens, in our garages. I have what my wife would say, a plethora of woodworking tools in my garage. And they make our lives easier. Ansible is one of those tools that we have available to us with all the open source stuff today to make our lives easier for us. So I'm going to let Carl and Paul talk about those. Let's talk a little bit first. Carl Burnett is a distinguished engineer with IBM Cognitive Systems Software Development. Carl's worked with his IBM career on multiple software projects in IBM, AIX kernel, distributed computing frameworks, the OS security, and distributed file systems. His current responsibilities include defining the technical strategy and development plans for our Power Servers software products. All right, so his major focus is on cloud enhanced power virtualization, and flexible infrastructure integration. So Carl's really key to a lot of the power system software stuff that we hear about, and we're lucky to have him on here to talk a little bit with us. Also presenting today is Paul Finley. Paul is a senior software developer with IBM Power Systems. He is a subject matter expert in all kinds of aspects of cloud image management, which we'll hear about today, security, digital verification, image capture, configuration management, and system deployment. He's a lead engineer helping to deliver on the Ansible modules in AIX. So we've got two very expert people here to talk with us today. With that, I guess we're going to hand it over to you, Carl, to start. Carl, can't hear you yet.
Is that better, Joe?
Yeah, there you go.
All right, sorry. Thank you, Joe. And thanks everyone for joining. I see we have over 1,000 people now on this session. That's just fantastic. I think we have a very interesting topic for you today, and I hope that you enjoy it. We will have some polling questions at the end. This is your opportunity to give us feedback, which will be very helpful to us as we prioritize our activities going forward. One thing I would ask when we get to the polling questions is that the IBMers on the webinar not respond. We're looking for feedback from clients, ISVs, and business partners that may be attending today. I like Joe's tool analogy around Ansible, and I sometimes have colleagues ask me what Ansible is. And the way I often explain it is it's like a very powerful universal remote control. I'm sure we all remember having more than one of those sitting in our TV rooms and so forth. And the way those things worked is you had a standard set of buttons that did a variety of operations, and you could literally point them at any of your audio visual devices, and it sort of worked the same across all of them. Examples would be volume control, channel up, channel down, things like play, pause, and stop. And this is an oversimplification of what Ansible is, and Paul's going to take you a little deeper in. But there's a lot of conceptual similarity there, and that Ansible gives you a framework where you can have a variety of tasks and operations, and you can carry those out against a variety of endpoints in largely a standard way. And Paul's going to, again, take you deeper into that. And so with that, Paul is our main presenter today. Paul is a senior member of our AIX development team. He really has been a thought leader around several areas in AIX, including install, config, cloud enablement with AIX. And he's also been leading several projects for us around automation over the last few years. So Paul today is going to take you through a brief intro to Ansible, share with you what we've been doing with Ansible and AIX over the past couple of years, and also share some viewpoints that we have formed around what we think would provide value for AIX with the Ansible. And then Paul's going to also try to do some demo for everyone today, so that should be pretty exciting. And with that, I'm going to turn it over to you, Paul.
Okay, thank you, Carl. Hi, everyone. Good morning. As Carl mentioned, my name is Paul Finley, and I'll be taking you through our Ansible deck. Let's start first with a little bit of common challenges and just an overview. I'll try and keep some pace to this presentation so that we have plenty of time for Q&A as well as demonstration. But if I'm going too fast, please text and let someone know, and then Joe or Carl stop me or pause. All right, so spend a moment on what configuration management tools are and how they're used to help administrators have an easier way of deploying new servers, rolling out updates, or just basically making sure that all the existing servers stay configured properly. All right. So the amount of time required to maintain environments grows quickly as our number of servers increases. And sometimes we find ourselves trying to understand, once we scale our systems to this size, how to keep with everything in front of us. So for example, what builds of levels of AIX are in my data center, what stack is deployed in certain clusters, or things such as are my systems vulnerable or out of compliance. So assuming you're able to meet those challenges, another set of challenges might occur when you actually attempt to roll out updates or fixes in these environments. Some of these challenges might be operational, some might simply just come down to skills, and having the right team with the right level of knowledge across several different platforms and architectures, really makes it difficult. So this is where configuration management has been proven as a solution in problem spaces described. And one of the things you can think about here is if I were able to automate a patch and update process, such as soon as the developer has finished a patch, we can actually roll out into the test servers. Well, that's where Ansible comes in. So Ansible allows for the automated deployment of programs, files, and configurations. And by the nature of how Ansible works, it will also recognize if something was changed from the prescribed state and also restore it to compliance. For instance, if someone were to remove a package or change a configuration file, well, Ansible can put it back to the prescribed state. So as a configuration management tool, we'll talk about this a little later, but Ansible solves a great automation and simplification tasks, and it makes it easier for us to now deploy in our spaces. So let's dig a little bit into this Ansible-based terminology. And I'll kind of start by talking a bit about playbooks, and then I'll talk you through the control machines and machine nodes. So playbooks, they're the blueprints that get executed. And this is how, when you define what you want a server to look like or how it should be deployed or configured, it takes that in form of a playbook. The playbooks are written to be idempotent. So if a task has already been performed successfully, Ansible can actually check and see if the state is of a proper value. And if that state is recognized, that means the task doesn't have to be repeated. I won't go into much detail in our presentation, but just so that you'll have as an example, when you specify a state in Ansible, you specify that the state to be something along the lines of present or maybe absent. If things are specified as present, then that would explain to Ansible that things need to be installed or be in a certain configuration. If you modify things to be as absent, that would inform Ansible that things need to be probably removed or replaced. So the control machines, those are the machines that you have Ansible installed on, and they are executing playbooks from. And you can generally have one control node, or you can actually decide to have several others. In our example, I'll use one. And then what you want to know here is that Ansible is lightweight. So the configuration and connection through Ansible to your managed nodes is through SSH. That means Ansible require clients to be installed on any of the services managing, clients such as agents. And Ansible only uses SSH to control servers, so you're pretty much able to do anything that you can do over a standard SSH connection. Truly, the only requirement is installation of Ansible on one machine, that's your control node. And then once you have it on that control node / machine, you can then manage one-to-many as far as topology for your managed nodes. And the managed nodes are basically the servers that you're managing from the control machine. And this could be all of your servers you're running to actually automate tasks on, or it could be one machine that you're simply running against and maybe get information about. All right, so looking at how the deployment might look with Power, let's first start with this integral piece in the diagram, and that's going to be the Ansible engine. So Ansible engine, it's developed by Red Hat with the explicit intent of being used as an enterprise IT platform. And this engine has a collection of modules that have been developed and maintained by Red Hat engineering, and those modules are labeled as core within the Ansible framework. So the Ansible engine also project community modules, and those modules are maintained outside of Red Hat services. And users can select from an exhaustive list of the included modules to automate every aspect of the IT environment. And so with your Ansible engine, you have connectivity to what we describe as endpoints. So the Ansible endpoints, and I'll list those a little bit for you. Let me try to scroll down. Those endpoints are the operating systems in which Ansible modules will run, and they can be any flavor of OS. And really, from an IBM Power Systems perspective, This may include Linux on Power, IBM I, and AIX, which is what we're describing today. But it could also include other operating systems as well, such as x86 Linux. And this provides for a consistent Ansible management experience across our data center. Moving over to the Tower, we'll see that Red Hat Ansible Tower provides a more centralized and controlled view of the infrastructure. And it's really what's being used to manage Ansible Engine. And those features might include having the visual dashboard that I'm going to show you, role-based access control, job scheduling, but I'll also show you the graphical inventory management, and it's pretty nice. So let's go back and talk a bit about Ansible Engine now, and some of the Ansible concepts that we'll need to understand for demonstration. So host inventory files, those are used to define the IP addresses of the servers we're wanting to manage, can also be listed as hostname aliases. And you can group these systems and have the groups defined as using things such as all, or have group names that you can use to execute specific tasks on. I'll show you in a demonstration how we use groups to define things such as AIX groups, as well as NIM groups. The NIM groups is pretty slick because using that, we can run a playbook against inventory that may only contain one NIM server, but that NIM server would then be able to perform actions specifically deemed responsible for an install of the system. And then what happens is when you're running, these modules are really what gets copied down to the endpoints. And those modules, those are like the methods that actually get executed. And those modules are being driven through your playbook, and they're what contain instructions for various tasks, and we call those plays. And the module languages, but the ones particularly used in our environment are going to be Python-based. And in many ways, Ansible is, platform agnostic. For instance, if you look at this diagram here, you'll see that we're running Tower as well as Ansible Engine on a Linux, x86 Linux actually. Then from this Linux system, we're able to then have methods copied down to all the endpoints. As long as we're running Python on these endpoints, then Ansible really doesn't care. Python can run on all your power systems, IBM AI, as well as x86 or UZ. All right, so as I mentioned, I'm here because I'd really like to show you a lot of the demonstration. So let's go on to Ansible for AIX and what we're doing here. So what's going on? So the first set of content will actually center around patch management and security vulnerability checking. And I'll discuss some of this in a couple of slides later in the deck. And one thing to point out is that a majority of our AIX contributions are to be delivered as modules with not as much emphasis on playbooks from a collection standpoint. But there are some examples where playbooks may find to be useful. And so we might have small examples that we'll list out in a public GitHub space that users can, copy, reuse, modify. But from a delivery standpoint, playbooks aren't something that we consider of much value. One thought around, playbooks is if we do find a need for them, what IBM may look to do is to start contributing towards roles as opposed to just base playbooks. The roles are more like the smaller playbooks in essence. And they allow us to break the playbooks up into modular parts. And then if we break them up into modular parts, well, then the playbooks in terms actually becomes reusable. But a base playbook is not reusable, meaning if you have a playbook written and it has specific plays that are performed, that playbook is considered exclusive from others. Find them as roles. So perhaps IBM would look to invest some in roles, but we haven't decided just yet. And then the community provided OpenStack animals. We're actually going to show you those, and they can be used to automate several Power BC operations, such as deploying a virtual machine. Well, that module is actually written around several different modules. And so those are grouped to this role that I described for deploying. And I'm going to show you how that works. And IBM has actually released that in addition to another set of modules inside of what we call the IBM Cloud collection. And that's now. So in the past, we've had some activity around playbooks in Ansible, and several different patching strategies around centralized management. And the centralized management was largely focused on NIM. And as you can see, we have some assets and collateral out here in the OSS site for Ansible Play. And with the centralized management, as I mentioned, it has NIM in the space, but what we also want to consider now is how to actually get endpoint management integrated into AIX. And that's what this project is mostly around. But if you'd like to see some of the prior assets we've defined, you take a look. There's some there for patching policies, and it can be used on 6.1, 7.1, or 7.2. Here's an example here of what the AIX Summa looks like. This AIX Summa is actually being driven by NIM. And so now we have a specific Summa endpoint module that we're working in addition to some of the centralized modules. So thoughts around what we're considering management. So our endpoint focus is going to be mostly around common management activities performed in the environment. And this right here is just a list of thoughts that we have around next steps to address, but it's not actually listed in any form of priority. Later, after this deck, we'll have some time to get feedback from you around things that you consider important. And assuming you have this desire to leverage Ansible in the environment, your feedback is going to help us understand where the pain points exist. And then based on that knowledge, that'll help us to deem what's critical and what we should go forward with in terms of where to focus our efforts. A couple that we have done in this example that I'm going to give you, we've done some modules, and we've done a couple of books around the patching for using iFixes and service packs, but we've also done a few playbooks around modules for AIX. And those include TL and SP versions. I'm going to show you some of that in addition to provisioning and install. All right, so where do we go with this? So the patching modules and the hand pick I just mentioned to you that we've been working on, those are going to be available from an IBM public repo, but in terms of future delivery, the idea is to have things in GitHub that can then be consumed by Galaxy. And in Galaxy, that's where you have the repo that Ansible supports for all the roles, books, and modules. So that's where we're hoping to deliver our content, and this might be an example of what that would look like. As I mentioned, this is still being explored, though, and we don't have anything there just yet in Galaxy, but this is how we plan to deliver it. And then once it's in Galaxy, you can easily add those into your Ansible automation platform by way of sourcing from the GitHub repo, or if it's being delivered as part of Red Hat, you would have that as part of your product. Again, those things have not been put into plan yet. Those are just thoughts we have around how we would deliver. And this chart here, it illustrates some of the IBM services solutions that are available around automation in Ansible. And IBM has a great team of technical resources that are capable of helping you implement some of the common sets of playbooks or even the customized plays based on your need. So keep this in mind as you look to introduce Ansible or even any other configuration management platform to your management landscape. You can reach out to your lab services team members if you're interested. There's a link for you here, and they can help explain more detail about the service and then also how you can use Power Cloud rewards, as a funding source. All right. So again, I apologize if I was going a bit fast, but it's only because I wanted to truly get to this. What am I going to show you here? So in the demo, what I'm going to do is I'm going to log into Ansible Tower. And from Tower, I'm going to explain and demonstrate to you how I can use Tower to basically deploy into a new Power environment. That deployment will be through provisioning using the OpenStack modules that I had mentioned. And then after we do that deployment into our environment, I'm going to show you how to then do some management of those systems. You'll see several systems in this space. Some will be AIX, some will be IBM. This demonstration will focus mostly on AIX. And one of the key things I'd like to show you is the patching. So we'll do a little bit of the patching demo, and then we'll take questions. And then from there, I believe we're going to have some polling questions to be answered. All right, so I'm going to end this slideshow. allow me 1 second to pull everything up. So while I'm pausing here, Carl, is there anything to mention, answer?
No, not specifically. I will say there's a lot of great questions coming in. I'm trying to answer some of them where I can. I'm trying to, Paul, there's maybe a few I'm kind of assigning to you that maybe you can cover at the end of the session. I think we'll have plenty of time, but a lot of great questions. One of the questions that did come in was around, are there services to help people build out an Ansible landscape around AIX? And as Paul just showed in the presentation, our Power Lab-based services team does in fact have some offerings. They've done 20 plus engagements with clients over the last couple of years. A lot of the engagements were around things like patching, both AIX and VIOS, but they've also helped some clients do Ansible automation around virtualization management against either an HMC or Power VC. So they've got some good experience and some good skills. If there are people out there that are interested in potentially a services engagement, myself or Joe can get you connected to the leader of that offering if you want to explore it further.
Okay, thank you, Carl. All right, so here's the dashboard view. We're logged into Tower, and one thing I'll start with is you'll see on this left-hand side, there are several different resources defined, and we're going to talk about most of them. We're not going to get into scripts, but we'll discuss templates, credentials, projects, and inventory. But one thing to keep in mind is in this dashboard view, you have a point in time, overview and oversight of what's actually going on in your environment. You can see successes and failures for these different jobs that are being performed. And if at any time you want to drill down, things are available from this job run where you see recent views. You can click and get details about every action that you performed or every action that's been scheduled for perform. So let's start with how you would do this. So in Tower, you'd first start with projects. I can get to it here, or I can select it here. So in this projects view, sorry, let me log in again. So from the projects view, I want to add a new project. And this new project I'm going to add, I'll give it a name, and it's Ansible. And when I define this, what I want to do is I want to first tell Tower where it resides. So I'm using the SCM, so I'm using a GitHub repo. So for source control management, all I basically do is define it by stating, here's the URL from where I want to grab all this content. This content is really how I'm going to load all of the playbooks that we're going to be using for this demonstration. But another nice thing is it can also load custom modules. So although the modules may not be available from Galaxy or any type of automation hub perspective right now, I can still obtain everything from my custom module, playbooks, roles would all be obtainable via public GitHub space, or I can actually have credentials where I write in private access through key access, key management. But for us, it's a public space. I don't need any credentials, specify the location. And then once it's sourced all that content, what it will do is you can then start defining these templates. And let's say I didn't have a template. I would go through the templates resource, and from the templates resource, I can define a new job. This new job template, we'd give it a name. Let's call it test. Actions to run. The inventory. This is basically stating for this job template, there's a default inventory that I'm going to use whenever I run it. This inventory can be changed, but for now, let's say I give it an inventory location of demo. If I want to, during each deploy, I can prompt on launch. That allows me to switch this as needed. But if you want to have it hard coded to a set, you can leave it as such. Providing the credentials. Let's do this first. Let's find our project. As we've done that, you'll see that the credential, and that's because now what we have is based on this project, there are playbooks in it. So here's where I could say for this test job template, I want to do a demo of a NIM check. This is the playbook that it's going to pull from our project. Now I give credentials for this demo inventory. I've created a new template. All right. So with that, let's look at a few that we have for power. Here's an existing templates that I had, and you'll see that there's a new template now based on the one that I just described for using a NIM playbook. Now that we have our listed and our project has been sourced and we have templates defined from that project, let's look at the inventory. Adding new inventory, it's quite easy. Here's a list of inventory that's already defined, and it has a list of host machines. These host machines, you can see I'm using hostname alias, but I'm also using IP. If I wanted to add a system to it, it's quite simple. You can do that here. But one of the things I wanted to show you here, you have inventory. One of the things you can check up front to determine if you have a connection to inventory by doing something like, let's say I want to run the shell module. For the shell module, I simply just want to run an ls. It's been limited to the system that I selected, but I need to connect to that system to run the module, so I need to give it a credential. The credential we're going to use, default root. Give you a list of verbose so you can see some of the default output that you can print. And let's launch it. Okay, so things to point out here. So whenever a job is launched, you'll see this status, and as it's running, it'll show it's either pending or running. But when it finishes, it'll move to successful. And this solid green shows you that it has been successfully completed. You can look to your right and see there's an elapsed time for how long it took the module to actually run to completion. After the module completes, all of the standard out as well as standard error has been registered. And when that has been captured, it's being presented to you based on a couple of things. In your playbook, you can specify how to present standard out, or you can simply have quiet and you don't want to have it presented at all. You just want to have, for success or failure, things that show whether I've changed or the state has already been present and does not require change, but it's simply at the state that I wanted to have it. For us, all I did was an ls operation. That's just so you can see we had a valid connection. It ran some actions against that system, gave us the output. But let's do something a little more interesting than that now. Let's go to our templates. I will show you a provisioning. All right. I'm going to do a provisioning demo. When I provision, what I'm going to do is I'm going to be pulling from the DevOps project. And from this DevOps project, I'm using the open source modules that are in this playbook called Create. It's going to connect to a Power VC system that we have, and it's going to define a new system and start that system up. And then once it's started, that system will then become part of our demo inventory. If I wanted to deploy it elsewhere, I would basically just state here, what's my target? What this really is as I mentioned, it's just a collection of the IPs and hostname aliases. This in no way has any modifications on your environment. So you can have multiple inventory lists. It just depends on where you want the deployment to complete in terms of the new addition to that list. It's not going to change anything on that system. It's simply going to say, for this one system, I want to add it to a list of additional IPs that I can then later do some queries against. But for the deployment, I'm going to a couple of changes here. What I'm doing is in this playbook, There are a set of variables that can be modified so that the playbook can have dynamic entries to it. Those dynamic entries are through Jinja. And so right here, Jinja is just a web-based template action. And so I'm stating that in the playbook, there are certain variables that have been defined and they have defaults. The defaults I'm using are listed here. But what I want to do is I want to be able to dynamically change some of those defaults. So I've listed the variable names here so that at any time I can change the groups that it's defined to. The flavor, it's basically information that Power VC will use to understand how best to construct and deploy our new system. So let's save. So by default, I'm going to use a VM name of AIX49 as our host name. The reason I did that is because I want to show you when it's launched. If I have this prompt on launch, you'll see it's stating that, okay, you want to do a deployment. You want to save that inventory name under and the same values and properties that I put as defaults. You can now see that if I need to, I can change those out. You can see here the variables that we had as defaults, modified them for this one particular launch. And what's happening here is that this pending status activity is occurring because it's pulling all the latest playbooks and modules from our space. Once it's pulled all that information down properly, it's going to run the job template. And it'll actually save this template off, and I'll show you here. While that's running, you'll see that it's showing that there's a job number sign, 568. Blinking, showing it's basically still an active state. And the action is performing its provision of the new Power VC system. So clicking on it, let's go back into it. You'll see it's been running for a while now. One of the things I should do is probably wait for this to finish just so I can show you an easy way to get status. Oh, sorry. All right. So it's almost done. Like we're running out of space. Oh, you've got to love real-time demos. Huh? Looks like we ran out of space. I'll have to delete a system. So let me do that, and then I'll continue, and then we'll come back. Let's kick off this deletion. Actually, let's run this one. All right, we're having some difficulties on the provisioning. Let me come back to it. Let's go back to our project. Let's take a look at some existing systems. Let's run some actions against them. All right, so some of the projects and templates that we have defined from Power, let's do this open source package installation. So what I'm going to do is I'm going to launch. I'm going to do this one against the AIX Cloud VMs inventory. Let's find the right credential. AIX root. And let's just install MariaDB server on those systems. Instead of checking to see if it can run, I'm actually going to run it. All right, so in summary, we're going to launch the playbook using the xCloud's VM as our inventory. Credentials here is just a definition of the key. That this SSH key is how we connect. We're going to install MariaDB server on those systems. One system, like its file system defined. So this list, 4 of them were reachable. Looks like another system's not defined.
Hey, Paul, while this is running, sort of an interesting stream of questions I'm seeing, I'm going to try to paraphrase it and get you to comment on it. But
Okay.
in terms of if you set up an Ansible environment around your power landscape, to manage AIX and other things, and you're leveraging a collection of modules, from various sources, such as our current OSS site, or maybe some work that's been done in the community, or things that eventually, become visible in Galaxy, or even Red Hat Automation Hub. I assume there are models where you can bring those collections of modules down local in your environment behind your firewall without necessarily having to open up, let's say, your power landscape to the internet. Is that correct?
Yes, there are ways you can do that. You can configure proxy servers. And if you do not have a proxy and you simply just have a system that has a local repo already defined, you can use that. Is that the question?
I think so. And maybe somebody out there who asked the question, might want to clarify it, but that's sort of the what I'm getting is the concept is, can you use Ansible against a set of systems without exposing the systems, the endpoints to, the internet?
Yeah, absolutely. As long as you have connectivity in your local domain, that's fine. And if it's just a matter of getting the right playbooks identified, that can easily be done by defining a local directory on your Ansible server. And so, again, you don't have to go to the outside realm to receive any playbooks or any of the modules. If they're local to the system, you can use those to deploy against any system that your Ansible server can reach. If you're in the same local subnet and it's a private net, it all deploys just fine. But if you're deploying playbooks that are requesting any content to download, such as a fix from like Fix Central, well, that's going to require you to do one of 2 things. You're going to have to give it outside access, or you can instruct your Suma service to either look at a local NIM repo, or you can have NIM configured for a proxy, or the local endpoint itself could have a proxy. And that's another way of bypassing the outside access. You can point it to a machine that can go outside for you.
All right, great. Thanks, Paul. And another thing I saw in the Q&A, if you have some time towards the end of the demo or sometime during the demo, there was a couple of questions asking if you could show invoking, some actions straight from the Ansible engine, or the Ansible controller component, as opposed to Tower. So maybe something you can do somewhere in the session.
Okay, sure. All right, so what I'll do is, while it's doing the open source install, and there are actually several systems that it's installing too, so it's taking a bit of time. Let me show you real quick how you would reinstallation. I'm going to use install resources on a NIM server. And the reason I'm using the NIM server is because I want to have that boot capability in bare metal. So I'm going to use a NIM management playbook. This playbook is based on activity that we had in prior engagements, and those are still sitting out on an AIX open source software site. So this is just an example of a playbook that currently exists that you can even use today. And I'm going to do this by first connecting to the NIM server, and the NIM server is being determined. Let me show you this real quick. Sorry, it's not going to make sense unless I show you this. So inventory, as I had mentioned, on our cloud VMs. This is a list of VMs under this cloud inventory, and you'll see one in particular, is Regency 1 CO1. This guy is actually defining a group that I call NIM. And so, although my playbook is going to be executed against this entire set of inventory, only the one defined as a group of NIM will be addressed for NIM actions. And that's because the playbook itself is written in the sense that it asks which host group. And if you're in the NIM group, it'll run plays against it. If you're not within the NIM group, it does not run a play against it. It does not mean there's a failure. It just simply means the condition has not been met until it finds a system that's actually in the valid group state. So back to the template. And also keep in mind that using the NIM resource group allows us to install against NIM. So it's not only systems that are understood by Ansible, it can be any system that NIM has access to. So this system that I'd like to install, I'm going to call it MB05, using the basic resource group. And again, if I had another list of resources, then I could define them here. Let's launch. So you'll see in this play, I'm actually connecting to systems that are under our cloud VMs that are of the group NIM. It has found one, it's Regency 1C01. So from Regency 1C01, it's passing instructions so that Regency system named Quimby05. And you install that system with resources that are in the res group. If I want to see the list of resources in this group, one thing you probably want to do is connect via SSH, or you can actually write tasks as part of your job status here in Ansible Tower if you didn't want to connect back to that system. And while this is running, I'll just kind of explain how that could work. One of the things you can do is when you're running against a system, as part, you don't have to run a playbook against it. You can state, I want to run the command, as I showed you with the ls. Well, instead of running an ls, what if I were to run something like an ls nim action? Well, I could do that to get information about the resources that I have. Having that information would then allow you to understand what I can place, as a replacement for the resource group that's by default. Well, that default resource group could be then modified with the output that you got from LSNM. So that's how I was able to figure out the resources that are in here, by the way. And as you can see, the output is showing us that it has succeeded, which has been made on Regency. That changes to do this boss install. Boss install action has been performed against Regency 05. If I want to drill down into that, I can click. And the output gives us more information about what has happened here. This is listening about Python. Boss install is completed. Here's the command, boss inst. Source B, makes B is coming from basic res group, MB05. Change equals true. And this is just saying there was nothing to be performed separate from it. All right, so this is good. All right, so while that's running, let's say I want, you can see where the status is on the other jobs. This was the one we had ran a while ago. See what failed in this job. All right. So from that output, we can see that several things happened. This is actually good that it failed because this gives me a chance to talk about it a bit. You'll see there were 2, 4, 6 systems that it ran against. Of those 6, OK equals 0 means it was not able to reach it at all. Unreachable is 1. But if it were able to reach these machines, then you'll see each task in the playbook that it was able to perform. There were 5 tasks total. Of those 5 tasks, 3 actually happened here. And we'll look and see which 3 actually occurred. And of the 5 tasks that were possible, only 1 was performed here. Let's look and see what happened. Okay, so for Regency 1C01, you'll see that the playbook had several tasks, but only 1 was executed and it failed, so the rest did not run. That failed task was that it ran out of space. This system was out of space, so the rest of the plays in the playbook were not able to run. And that's why it's at OK equals to 1. For other systems, let's pick one in particular, this Quimby05. All the tasks were executed on here. And it's simply saying that the package MariaDB server was already installed and it was up to date. So that's why you'll see all tasks were able to execute, but the change state only equals 2 because some of the things were already done. There was no need to continue. One that actually installed was Quimby01 though. looking at QuickBuild 1, you'll see 5 tasks, 3 were changed. One of those changed tasks was the actual installation of MariaDB server. It's unfortunate that it's not honoring the return character. So it's all in one line, but I hope this is visible and it's easy to understand. It's basically showing you all of the software that it had to download and install. So in that playbook, it's actually using our AIX yum command to download all of the necessary from a local repo. But I also have it configured to use the remote resource server as well. So Yum is able to connect to AIX open source software site and download. But for this particular task, I'm using a local repo just because we want to make sure things in the local realm are being used and I'm not having to connect to the internet. All right, so we've performed a few tasks. You can see here recently used tasks. I can then see how many runs have been performed over the span of time that I have listed here. So over the span of time that we have listed here, how many times we performed a scan for security vulnerability? It's happened 6 times, 50% success rate. Most of the time during failure, it'll tell you that as well. This means FlirtVC was not able to connect. And that's because on some of these systems, for testing purposes, we purposely have them in an environment where they cannot connect. Oh, sorry. I forgot we're actually installing Quimby still. QuickBuild 1 is running though, so we'll wait for the FlirtVC output. It looks like we're coming up on time, so while that's running, let me show you the Ansible Automation Analytics Hub.
Paul, you have an extra 30 minutes here.
Oh, I thought we needed time for our Q&A and polling, but I'll spend only about 10 and then I'll stop.
We want some of that, but we have like another 30 minutes after this, so you can still go into that a little bit and we'll still put up the polling and
okay.
talk about questions.
Yeah, so Paul, why don't you plan on taking about another 10 to 15 minutes?
Okay. So from analytics, from our Ansible platform, we can look at analytics and see what's been happening in our environment. It's a real good view of the landscape and tells us a lot of detail about some of the tasks that are being performed, tasks that were performed in the past, and how that kind of plays into the overall usage in your environment. So you'll see modules are the gather facts, debug, FlirtVC. And over here, you can see some of the top templates that have been used are like open source package installation, scanning for security. If I click on that, I can then see how many runs have been performed over the span of time that I have listed here. So over the span of time that we have listed here, how many times we performed a scan for security vulnerability? It's happened 6 times, 50% success rate. Most of the time during failure, it'll tell you that as well. This means FlirtVC was not able to connect. And that's because on some of these systems, for testing purposes, we purposely have them in an environment where they cannot connect so we can get information about what that looks like and how to have user recovery steps. But over the last 3 times, you can see it'll show you the system it connected to, when it was started, total time it took to execute. 3 minutes so we can get information about what that looks like and how to have user recovery steps. But over the last 3 times, you can see it'll show you the system it connected to, when it was started, total time it took to execute. 3 minutes and some change, 4 and 4. So on average, it takes about 4 minutes for it to connect to the outside world, determine if there are any vulnerability patches required. If so, minutes and some change, 4 and 4. So on average, it takes about 4 minutes for it to connect to the outside world, determine if there are any vulnerability patches required. If so, download those to the system, patch the system, put it in a present state. So let's go and look now to see if on our dashboard, Let's go back to download those to the system, patch the system, put it in a present state. So let's go and look now to see if on our dashboard, let's go back to provisioning. And this was the error I wanted to resolve. So let me run provisioning. And this was the error I wanted to resolve. So let me run delete VMs. And I believe the one we wanted to delete. Pull up the name. Delete VMs. And I believe the one we wanted to delete. Pull up the name real quick. Sorry. Name real quick. Sorry. All right, I had to hop on the Power VC real quick and grab the name. This guy. I'm doing this because we're running out of space in our storage. So let me delete a VM, and then I'll see if I had to hop on the Power if I can do the provisioning step one more time for you. All right, so I've deleted the VM. Checking for a failure here. Okay, looks good. So back to our templates. Try this provisioning step one more time. I'm going to see if I can add back. I know in the past was present. Let's see if I can install it now. All right, so what it's doing now is connecting to Power VC to get an image list for image assets that we have. It's determining if the one that I want to use is present. If it is present, then the next thing it's trying to do is determine if it can create a VM based on the flavor that I have prescribed. And if I have resources that make that possible, CPU, memory, things of that nature. You can see so to get a response, it's able to do the actions. It's trying to create the VM now. And if that's successful, I'll be able to drill into that and show you what that output looks like. Usually takes about a minute. So we're right at about 32 seconds of elapsed time. So we'll give it another half minute. And just so, you know, for clarity, the creation is quick. The thing that we're actually waiting on is for the system to then boot. You'll see that create VM instance. It was able to finish that in about less than a minute. But then what we have to do is we have to wait for the connection to the VM, and that happens after it's actually booted and the service is active, SSH service is active. So total elapsed time from when I selected run was 1 minute and 38 seconds. Okay, almost there. All right, looks like it was able to connect. We have output, we're done. Total time is 2:54 now, so about a minute was spent with the boot and waiting for SSH to become responsive. Taking a look at what happened here, let's look at the retrieving available list. Let's just click on this real quick. Looking here, you can see things that it wants to understand. It wants to know if the systems are accessible, if we have enough information to do the and if it has enough information to do the deploy and the system creation is successful, then it prints all this JSON data back to you. And you can collect this data, as I mentioned, by registering an output. If you register an output, you can actually take this and then do some intelligence on it, such as assertions or spawning additional plays. All things can be added to a playbook. Right now, I just wanted to show you a deploy, but the nice thing is that after I've deployed, what I could have then is a playbook as part of this task that states, okay, during successful deploy, I want to deploy an entire stack for, let's say, MariaDB, or an entire stack for DB2. So things of that nature, or even start up in a web server. So those are things you can do after you've done a deploy. So it's real nice, real slick. I think we spent enough time on this. If you still want to see local Ansible, let me do that now. Let's see if I can get you a window that's viewable. Let me. Hopefully this is dark enough. All right. So let's see. Let's do one here. This one's against them. I'm gonna run it against all. No, actually, let's do it against them because I know them. Know that password. I don't know all the passwords. I'm using credential keys on most of these, but I do know the password for the NIM server. All right, if I had a playbook that I wanted to run, let's here. All right, so I'm showing you here real quick where all of the playbooks and the modules are all being stored each time you define a project. So by default, this var-lib AWX projects directory on this Ansible engine machine is where each time I define a project, this is where Ansible Tower will store them. And so you can see in here, let's say the one for Ansible for Power. That one's actually in this subdirectory that Ansible has created called _26 _ then it gives a name. So if I look under there, you see all these playbooks. And let me show you what some of the playbook content looks like for, yeah. So this is the playbook actually gets executed whenever I run one of the templates over here that sources demo_yum.yaml. For example, under templates, let's say I were to use this update open source packages. See here, demo yum YAML. Whenever I run this update open source package template, that's what's actually getting executed. It's the all of the content that's here. And as you can see, one of the things it's doing, it's installing all software, put it in a state of latest, meaning if it's not present, install it. And if it is installed, do an update to make sure it's at the latest level of software, excluding the kernel. The reason we're doing that is because I want to update the software, but I don't want to move the OS kernel level because I'm not at a point where I want to reboot or take a system control effect. Things I want to do while I'm updating, though, is by default, I want to do a yum install of anything that's under this asterisk. But in the template, you'll see for variables, I could specify something different. I could say I only want to do the yum update, but I only want to do the yum update against this particular set of software, meaning I could say this was for networking services or any type of application or any OS stack data. Those are the ways in which you can use Ansible in a tower perspective. It drills down into do something local. So if you run this from your Ansible system locally, you would do this. You'd go Ansible Playbooks. If we do Ansible Playbook, let's use Playbook. And the 2 and 2.7 are in case you want to use older levels of Python. For us, our Python levels are fine. And so the Ansible Playbook that we're using is on the latest version of Ansible. We'll run Ansible Playbook and we'll give it this demo yum. In this playbook, it's going to run against host equal to all. All right. So before doing that, let me show you. For our Ansible. Under here. Oh, I don't have one defined. All right, so what I'm doing here is when I'm using Tower, I don't have to have a list of hosts defined because Ansible gets all the information from a set of data points that's passed down to it from Tower. But if you're local on your system, you have to have an Ansible file. I'll show you what one looks like on a system that does have it. Let's see if I can find. Let's go to isotopes. Sorry. This one doesn't have it either. So I placed it elsewhere. No, I'm sorry, I don't have any system defined with it in this lab. But what I wanted to show you is that you can run the same playbook from the command line and you get the same output that you see here as part of this job status. The same output that you would see here is the same output you would get on the command line. It just wouldn't have all of these, debug informations about how the task was operated. Instead, it would show you just the output from the task. So this output here is what you would have seen on the command line. But this system's not configured for it, I'm sorry.
Yeah, Paul, this is Carl. I think we might be at a good point to wrap up the demo. Maybe start the polling questions, and there's a couple of sort of themes I'm seeing in the questions I thought maybe you could talk to while people are working through the polling questions.
Do I need to stop sharing so you can do the polling questions? Because I don't
No,
have
I don't
that.
think so.
Okay.
Let me see if I can put up the polling questions.
Okay, great. So, Joe, while you're doing that, so Paul, one of the themes I'm seeing throughout a lot of the questions is around, I'll try to paraphrase it, but what are sort of the basic steps to prepare an AIX system, to be ready for Ansible management? A lot of questions around, what Python do I use? What about SSH? Are there any other prereqs I need? So maybe you could just briefly describe, once an AIX system is, sort of installed with a default install, what are sort of the, basic steps to then make it ready to be used underneath Ansible?
Okay, sure. So when you install a system, there are only two real things that have to be put in place. Let me share the screen environment one more time. The two things you have to do is one, you need to install Python. And after you've installed Python, then the only other thing is to make sure this system can be accessible from Ansible, and that's through SSH. So let me darken the screen so you can see a little clearly here. All right, so here's the system. So I need to install Python. So to install Python, if I have yum, then I can search for Python. If Python is present, then I can do a yum install and install Python.
Okay, I'm going to go ahead and open the poll.
All right. Okay.
Thank you, Joe.
There's several questions here, guys. So go ahead and as Carl said, if you're an IBMer, don't answer the poll questions. Let's just get answers from customers, BPs, ISVs, and that sort.
And Joe, let me put a little context around the questions, especially the first 10 or so. Everyone might remember that Paul showed a set of use cases in his presentation that we think are important use cases for Ansible management of AIX endpoints. And so what we've done is we've taken those use cases as well as a few others here in a list. And what we'd like you to do is tell us, whether for each use case, tell us whether you think it's not important, somewhat important, or very important for as a use case. And that will give us better insights into what you, our customers, think are the most valuable use cases for you with Ansible management. And this can definitely influence our future direction. So that's the bulk of the questions at the beginning. And then there's just a couple at the end where we're trying to better understand what you might be doing with Ansible today. So hopefully you can work through these fairly quickly, and we really value your feedback.
Okay, so while they're doing that, so I have this system and I've confirmed that Python is present. This is going to do an update of Python. I'm not going to update it because I want to first show you this. Once you have Python installed, and again, you can do that using yum install Python. Once it's installed, you have to make sure SSH is running. And I did that by running lssrc -sshd. If SSH is running, then all you have to do then is get these keys copied over from your Ansible engine over to this machine node. Copying those keys is as simple as editing the file itself, or you can use the SSH key copy command. Once those are copied, that's all you need. You have Python present, you have SSH connectivity. That means Ansible can connect to that system, and now it's able to copy down the methods. And once copied down, Ansible will execute those methods, return back the status, and then Ansible will remove anything that it copied to this system. Everything is in a temp directory space that Ansible has created. That way it can easily blow that away once it finishes.
Thanks, Paul. And then another sort of theme I saw in the questions was around the need to provide root access, or is there a method to invoke actions on a system without root? So maybe you can explain just a little bit this sort of the security considerations that one needs to keep in mind when using Ansible against endpoints.
Sure, Carl. So the easiest thing is to use root, but most people won't find that to be the most practical way. It's easy, but it's not the most sensible. So what you can do is you can define keys that define what a user connectivity should look like. If you have a user, let's call it the Ansible user. If you create that Ansible user and you give it SSH key access, and what that means is I don't have to log in as root to this D68 base system. I can actually have it connect as an Ansible user, and then as it connects, it can run all of the methods that it needs to run. Those methods, any commands in that method that require privileged access, that privilege would be then elevated based on the permissions set on your system. If you're connecting as an Ansible user and you're doing SSH key for the root access, you don't have to elevate any privileges. It'll just run as is. But if you're connecting with a user and you're not using SSH keys for root, then what that means is whatever method commands are being run on the local shell will have to have the right privileges for the subcommand. For example, if I'm running a command for install p, I need to make sure that I either have install p being run as root, or I have to use an SSH key to connect as a specific user that can then have root privileges elevated. If I'm only doing something as simple as running things from a local system or a local user, I don't have to have.
So we've got about 40 seconds left on the poll. I know, Carl, you've been really busy looking at those questions. There are a lot of questions out there.
Yeah, I've tried to answer the ones that I think I know the answer to, or that I can provide some information on. And I see there's a lot of questions that are around, like, what are plans? And so we are on a session here that is not covered under a non-disclosure agreement. So we really can't talk about our plans and roadmaps. I do appreciate all of the questions. I've tried to take some notes for myself. There were questions around, what about alt disk install models and multi-boss? So we can take some of those feedbacks and look at those as we are planning our future activities around this. So definitely appreciate all of the activity on the Q&A.
Okay, we closed our poll then. Hope everybody had a chance. I know there was a lot of questions there.
Joe, can you actually show the results to everybody? We have a few minutes left just to let people get a snapshot of how. There we go. Thank you. So I can see a lot of these use cases, or almost all of them, are viewed as pretty important. Some less than others, but this is valuable for us. So I really want to thank everybody for doing for answering these questions. This is really going to help us build the right things, right, and deliver the value that we'd like you guys to experience. So definitely thanks everyone for responding.
So Carl, can I ask a quick question? I see this is very similar to one of the other polls we had on another session, and people find BIOS patching very important. But I'd like to know, do you see this as being BIOS management by way of endpoint? Meaning, would you want Python and SSH connectivity on your BIOS so it can be managed directly from an Ansible engine? Or would you find value in what we're currently doing with our centralized management through NIM, where your BIOS doesn't require Python and it doesn't require any connectivity to anything aside from a NIM server. That way, the NIM server can run commands using the NIMSH daemon, and then it requires you to open that BIOS up for any outside activity to the world, because NIM will copy down everything that it finds over in Fix Central as well as local repos.
Yeah, so Paul, it's interesting you asked that. I mean, I saw several questions around, Python on the VIO and things like sudo and so forth. I know that the work that the team has done so far has been around managing BIOS through NIM for things like patching. And I guess an interesting question for us to go off and look at in our team is, does it make sense to allow for direct, management of BIOS, especially since our strategy really for the last few years is to try to make it so that customers don't have to directly touch BIOS anymore, what we've called no-touch BIOS, by improving our, management capabilities in areas such as HMC. So I don't know, maybe there's a large audience out here, but if there are, folks that have very specific thoughts around what you'd like to manage directly on the VIO, maybe you can provide that back to Joe, and Joe can pass that along to us.
Absolutely. And feel free to put stuff in the chat right now if you want, and I'll capture that too. We can pull stuff out of there, or you can send me an email.
Okay, so Joe, I know we've got just a few minutes left. I just again want to thank everybody who joined us, and it's great to get such a large audience. We think this is a very important topic in an area where we can again provide value to our clients. We are putting in a lot of effort in this right now, and part of it is sessions like this that allow us to do the user research so that we can build the right thing.
Absolutely, and thanks everybody for, I know there are several people that either got in late, and those that are on, it's a good thing you got in because we did hit our limit. Some people think we can only take 1,000 people, and some people got turned away. So fortunately we have a replay, and if you're listening to the replay, you didn't get in eventually, sorry about that.
And Paul, thank you very much for taking us all through this today.
All right, no problem. Thank you.
All right, so just to wrap up, Carl, Paul, thanks so much. It was a great webinar. I'll put the replay out there on YouTube and a link in the wiki as soon as WebEx has been taking them. I guess they're big surge with all this work at home too, but as soon as they get it formatted and downloaded for me, then I can put it up. But thank you, Carl, and thank you, Paul. I really appreciate it. For everybody that's still on, when you exit and you get the survey, please put some comments in the survey and tell us what else you'd like to hear about as well. So I guess with that, we'll end the webinar. Thanks, guys.
Thank you.
Thanks. All right, bye.